This paper from last year looks at humoral immunity induced by an XEC monovalent vaccine against SARS-CoV-2 variants such as XEC, LP8.1, MB1.8.1, XFG, and BA3.2. This is a study out of Japan that looked at two different vaccines, an mRNA monovalent vaccine that's targeted to XEC, and also a self-amplifying replicon vaccine, also targeted to XEC. So two different types of vaccines. What they're doing is they're collecting blood serum before and after vaccination. So they have a pre-vaccination and a post-vaccination value for being able to neutralize an antibody response to COVID. So being able to kill COVID to a 50% level. That's what their target is. That's what they're looking at. And they're doing this 3 to 4 weeks after vaccination. The reason that they're waiting so long is that it takes us about 2 to 4 weeks to mount an immunity response on average. Most people take about 2 weeks, so they're targeting that 3 to 4 week range because even though some people might start to go down from their peak, this is going to give us the best chance of hitting the peak for the most people in terms of the study. And then they're also testing this against different variants of COVID. And again, this is a study that's from 2025, so it's going to be comparing also to LP8.1 vaccines produced by Pfizer. And one of the really interesting things that these authors did, which I haven't seen before, I think this is awesome, is that they used a lentivirus-based pseudovirus to harbor the spike proteins of these different COVID variants. So instead of dealing directly with each of these COVID variants individually, they have basically a host virus, and they're putting the spike proteins from each of these different variants onto the host virus so that they can present them. So this is going to reduce the biosafety level that's needed to actually do the study. So this is a technique that could probably be used and adapted to many different laboratories to make it easier to study the vaccine effectiveness against different COVID variants. So this is the meat and potatoes of their paper right here. So to the left is the mRNA vaccine. To the right is going to be the self-replicating vaccine. Both of these are going to be targeting XEC. So if we focus to the left here, XEC is going to be about a 12 times increase pre and post vaccination. This gray bar down here is going to be essentially no immune responsiveness. So everyone's going to have a different responsiveness, but on average, we're having very high increases in neutralizing titers for this XEC specific. And then when we go to variants close by, like the JN1, the LP8.1, the NB1.8.1, we're still going to have very high neutralizing titers, the ability of our immune system to recognize the COVID and then destroy it after being vaccinated. But then we see that with some older lineage variants like B1.1, BA.5, we're having still a boost in our ability to detect and destroy the COVID from the blood serum, but not as much. We're having a 2 times increase, a 3.2 times increase. And also with BA3.2, that emerging lineage cicada, we're having low levels as well. And then if we look over here to the self-replicating vaccine that they're also testing in the study, we see that there's across the board much lower levels of immune responsiveness. So this is showing that this self-replicating vaccine is not as effective as the mRNA vaccine, just purely from the study itself. And interestingly, the XEC is actually slightly lower on average than the neutralizing ability of the MB1.8.1. So that's an interesting thing in the study, but we're going to call them essentially the same. But also, again, we're seeing the same types of trends where things close by are going to be similar antibody responsiveness, but lower levels the further away you get from the target variant selection. But you're also going to be getting that slight increase for older variants and then also for newly emerging variants like BA3.2. And then this is an antigenic cartography map. So what it's going to be doing is showing us that one of these little boxes is going to be a twofold change in the neutralizing ability of the vaccine between one box to another. So if we look at the variants here, we've got BA3.2 way over here to the left. We have XFG way down here. We have NB1.8.1, LP8.1, and XEC over here. So this brown is going to be what this specific vaccine is targeted to, but then we also have the Pfizer BioNTech vaccine for LP8.1, again, right here, that variant. And what we're seeing is that this is essentially all of the variants that were tested against the sera from this data that they're referencing. So this is going to include data from this study, but also some other studies as well that they're going to be referencing. So we have the sera from the XEC as these brown triangles or squares. We have the Novavax and the Pfizer LP8.1 with these pink ones. So we see that both in the 2025-2026 vaccine targeted to LP8.1, and with this experimental XEC vaccine, we see that there is broad immunity coverage for most of these variants. But that there is very little coverage from these vaccines, if any, for both XFG and then also for BA3.2, which means that the old vaccines aren't going to cover these new emerging variants, which means people are going to be more susceptible to infection of things like XFG and BA3.2, which is what we saw in the data earlier. And we'll quickly look at this paper as well, antigenic and virologic characteristics of SARS-CoV-2 variants, BA3.2, XFG, and MB1.8.1. And so what are the three things that are important for a variant to start to emerge and take over the landscape? Well, it needs to be able to escape prior immunity. So this is escaping the prior vaccine coverage, which XFG and BA3.2 do. And we have the benefit of foresight now 6 months later to know that's exactly what happened. So that's one thing that has to occur. The second thing, they need really strong ACE2 binding affinity. So the stronger the binding affinity, the less virus you need to have a productive infection. And then the third thing, so you need immune escape, you need strong binding affinity, and then you need high levels in infectivity, so releasing enough virus to successfully infect other people. So these are the three different things. And if we look at this quick correspondence, we see that for ACE2 binding affinity, BA3.2 has very strong ACE2 binding affinity. XFG has pretty strong as well, but not as strong as BA3.2, so BA3.2 is superior in that respect. But if we look over here to infectivity, we see that things like LP8.1.1 and B1.8.1 have much stronger infectivity, while BA3.2 has low infectivity. So what we've seen is that, from this data, we see that there's very low growth advantage in this upper right chart right here. BA3.2 has low growth advantage, but things like XFG have very high growth advantage, as well as NB1.8.1. So we see that just basically, BA3.2 has 2 out of 3 of the formula. It has strong ACE2 binding. It has high immune escape from prior vaccination, but it doesn't have high infectivity. XFG actually has pretty much 3 of 3, or maybe like 2.5 of 3. So it has good infectivity. It has a high growth advantage. It escapes prior immunity to a pretty good extent. And then it has pretty strong, not the best, but pretty strong ACE2 binding. So it's basically like a 2.5, 2 out of 3 to basically a 2.5 to 3 out of 3. So that's why we're seeing XFG thrive like it is and BA3.2 not growing as fast as it should. But does that mean BA3.2 is not going to have the capability to do that? Well, no, it can garner mutations that can increase its infectivity, and then it would really be a strong contender to take over our current COVID variant landscape. Or it could recombine with an XFG variant, and they could create a new combination variant that would increase the BA3.2's infectivity, sort of like how we had BA2.86, the pyrola go into JN1, which led its own cascade of highly competitive COVID variants. And then finally, tying this into the present day, how does this impact our current vaccine decision-making at the VRBPAC meeting that was just a couple days ago in May of 2026? So we're looking at the LP8.1 vaccine over here for Pfizer. We're looking at XFG vaccine for Pfizer, and then the BA3.2.2 vaccine for Pfizer. So we're looking at 3 different sets here. So you'll see that the LP8.1 vaccine and the XFG vaccine have very similar coverage in terms of the variants that they're supportive of. But you'll see that for BA3.2.2, that's red bar over here in the middle, it's pretty low compared to the other ones. So if we select an XFG vaccine, we're going to have a pretty strong coverage in terms of like XFG and 1.8.1, some of the PQ variants, LP8.1, so it'll give you a strong coverage of most of the variants currently in circulation, but it's not going to do that well for BA3.2. Conversely, if we picked a BA3.2 vaccine, because it's so far away in terms of mutations from the XFG, you'll get a high antibody responsiveness to that specific variant if that's the vaccine selection, but you'll have a low vaccine coverage for everything else. So why does this matter? Well, the challenge is not everyone is staying up to date on their vaccines. So not everyone is going to have like the coverage from the LP8.1 vaccine. This is particularly challenging for children who don't have like our full breadth of vaccine coverage from the past 6 years of the different variant formulations. So it's better to have a larger breadth and then missing out on one than to pick like something that's growing. This wouldn't be a problem if everyone had gotten vaccinated and we had this vaccine history. It would be less impactful, but it would still be impactful for children. So this is sort of showing that there might need to be like two different vaccine weighing concepts being weighed against childhood vaccines and then adult vaccines, because it might be better to pick broader immunity for children since they're immune naive. They don't have the history that we do in terms of our vaccine history. While for adults, it might be better to pick like the next thing that could be happening, like the BA3.2, because it's so far away and we're not specifically targeting a vaccine against it. It's giving it the opportunity to grow and then become a problem for us. So that's sort of the challenge. The community ended up picking and voting on XFG, but these are the types of things that were in consideration during the meeting. And if you like this type of content, follow Patrick the Biostemist on Patreon. I do live paper reviews and coverage in full detail. This is just a short snippet of what you can see there.